So by now you might know how to expand a binomial or some sort of polynomial. There's some tricks you can do to make things a little bit easier on yourself, and there's some specific cases that are actually named. So I'm going to go through two of those special cases right now. But before we do that, I just want to get our brain juices flowing. I want to talk about squaring an item. So if we have 2 squared, we know that that's a positive 2, and clearly that's a 4. But what if we have negative 2 squared in brackets versus negative 2 squared and it's not in brackets? So negative 2 squared, the whole bracket right here is being squared, and we can essentially pretend like what we have is a bracket squared. And so we've got a bracket, we don't know what's inside it, times a bracket, we don't know what's inside it. Those 2 brackets were not empty like that. In fact, they were negative 2 and negative 2. And so a negative times a negative makes positive, and so that's positive 4. Now in the next case, the negative is not being squared. The squared is very specifically only on the 2. And so what we have is we have negative 2 times 2. And so in this case, the negative stays out, and this is negative 4. And that's going to be pretty crucial moving forward. It's something you should have already known, and that's why it's a recall. Now my second recall is just to discuss expanding and simplifying. So if we do have a polynomial such as this and we want to expand it, at this point you should know how to do this. If you would like to practice it yourself, I recommend you pause the video. If you already know how to do it, well, skip ahead to my next special case. But what we're going to do is we're going to multiply all the items in the first bracket times all the items in the second bracket. And you can do that in a couple different ways. You can multiply the y times the bracket and then the 3 times the bracket. So you could say it's y times y plus 7 plus 3 times y plus 7. And then you would distribute the y into this bracket and the 3 into this bracket. And there's absolutely nothing wrong with writing it down like that and doing it that way. But some other people find it a little bit faster if they just do it individual item by individual item. So we might say y times y times 7, 3 times y, 3 times 7. And so we would get y times y times 7, 3 times y, and 3 times 7. After that, we collect our like terms. My like terms here are the y values. I got a 7, 3. That makes 10. And now we have a expanded and simplified trinomial. So this is a trinomial. It has 3 terms in it. And that's something that, again, you should know. And this is a trinomial, a binomial, and a monomial are all subsets of polynomials. Okay, enough about that. Let's take a look at our first special case. This is called a perfect square trinomial. Now we're going to just take a little bit of a definition or another recall here. A perfect square. A perfect square is a square number that has a square root that gives a whole number value as an answer. So for example, 4, the square root of 4 is 2. 9, the square root of 9 is 3. 144, the square root is 12. There are no decimals involved. These are square roots that are easy to get. And those are all called perfect square values. Well, a perfect square trinomial, which is why I mentioned what a trinomial is up above here. Perfect square trinomial is a polynomial that comes from the expansion of a binomial squared. And so if I were to say 2 squared, that's 4, that's my perfect square. 3 squared, that's 9, that's my perfect square. X plus 1 squared, x plus 1 squared is going to create a trinomial, and we call that a perfect square trinomial. And there's a pattern to do this. We're going to talk about the pattern in just a second, but I want to show the breakdown. It's as simple as writing the bracket twice times itself, no different than what I was doing up above, and expanding it out. And you can totally do this the normal way. X times x is x squared, x times 1, 1 times x, and 1 times 1, and collect your like terms. But what we're going to discuss next is a pattern that allows us to go directly from the first line, the question, directly to the answer if you follow the pattern. Now, if the pattern I'm about to show you is too confusing and you'd rather not use the pattern, you'd rather just go ahead and do it step by step, there's no harm in that whatsoever. So we're going to expand and simplify a plus b squared. And again, you could write out a plus b times a plus b, and you could do the expansion. So we're going to do a times a times b times a, and b times b. Now there's no numbers involved in this, it's just 2 variables. And this is actually creating the pattern that allows us to go really quickly. So what we ended up accomplishing, if you take a look at the final answer that we have here and the final answer that I had in my example above, there's a pattern between these two. Can you pick it out? So what I have is I have the first term in the bracket squared. X became x squared, a became a squared. Then I have the second term, the 1 and the 1, and the first term, the x and the x, put together somehow. And it is now 2x. And in the second case, it is put together again, and it is again 2ab. And this is the one that confuses people the most, I think. And we're going to do another example here just to show the pattern more clearly. And then the last item, 1 times 1, that's 1, which is essentially 1 squared. And then b times b, which ended up being b squared. And so far what we can see is that we squared the first term. We definitely squared the last term. So we squared the first term, a became a squared. We definitely squared the second term, the b became b squared. But what's happening to this middle term? Let's take a look using this. I multiplied a times a, got ab, multiplied b times a, got ab. And then I add them together and got 2ab. So what we end up doing is we end up multiplying and doubling. We end up multiplying and doubling the two terms. And that is the pattern for expanding and simplifying a binomial squared, which creates a perfect square trinomial. So let's try that. We're going to square the first term, multiply and double, square the second term. So pause the video for a second, if you want, and give this a shot. We're going to expand and simplify this perfect square trinomial. Right now it is a binomial, and we're going to try and use the pattern. So again, the pattern is to square the first term. So we're going to square x, so that's x squared. Again, look at the pattern. It's square the first, multiply them, and double it. So x times -8 is -8x. So that's the multiplying, -8x, and double it. That'd be -16x. And square the last term. -8 squared is positive 64, which is why I went over those negatives and brackets and stuff like that at the beginning of the lesson. Let's take a look at doing that the normal expansion way. If I was to write, it's just a much shorter way. I can do it in one line instead of 3. So you get to decide which one you want to do. Just showing you a couple of tricks of the trade right now. So I do recommend you practice that a few times, and it's pretty easy to practice. Just make up a new polynomial, just make up a new perfect square, and just ask yourself to expand. And so just throw something in there like x plus 7 y or something like that, and try to make it a little bit more complicated for yourself. Put a couple extra little twists in there like -x squared y plus 1/2 y squared. Something like that. I mean, that's overly complicated, but I'm just trying to say, challenge yourself. All right, so the next one we're going to talk about, the next special case, is called a difference of squares. And a difference of squares is exactly what it sounds like. So difference means to subtract. So when you subtract two square numbers, like 9 minus 4, or x squared minus 36, a squared minus b squared, we're always doing the difference, which is what a subtraction is, of two squares. So that's a difference of squares. And we sometimes end up expanding and ending up in something like this. So we don't end up with a trinomial, which is kind of interesting. So if we take a look at this next one, x plus 4, x minus 4, and we're going to notice a pattern. Today is all about finding these patterns. X plus 4 times x minus 4, we can expand that out. And we're just going to expand it out the normal way. There's no real trick just yet. So x times x is x squared. X times -4 is -4x. Positive 4 times x is positive 4x. And this is where we can see I've got a -4x and a positive 4x. That's going to turn into 0. And then 4 times -4 is -16. So I end up with x squared. These went bye-bye. That's nothing. That's 0x, so the x term is gone, minus 16. Now x squared is a square number, and 16 is a square number. It came from 4. And so I've got a difference of squares. And so we can see that there's a pattern here. If I have a binomial and one of them has got a positive in the middle and the other one has a negative in the middle, multiplying a binomial times a binomial with the same terms but a different sign in the center, that's going to create this pattern, a difference of squares. Let's try that. You can do this one yourself. Pause the video and give it a shot. I didn't put any numbers in it. So what happens when we do this? We're going to get a times a, which is a squared, a times b, which is ab, b times a, specifically negative b times a, and b times b, negative b times b is negative b squared. Well, if I'd have done the pattern, and if I'd have just used the difference of squares patterns, I would have recognized this is a and b, one's positive, one's negative. I'm going to end up with the first term squared minus the second term squared. Done. Because a positive ab and a negative ab make 0, and they're gone. And so that's another one that you could challenge yourself or just try yourself. If you had y minus 3 times y plus 3, what would you end up with? Well, this is the same binomial just with a different positivity or negativity, a different sign in the middle. And so I'd end up with y squared minus 9, because 3 squared is 9. And that made a difference of squares. And you can easily just make up questions for yourself that way. So with all things math, practice, practice, practice. It's the best way to learn different techniques and get better at math in general. Thanks for watching. If you have any questions, just let me know. And stay tuned for more videos.